Welcome everyone to our Chapter 3 to 2 September gathering. 1st of September was spring in South Africa, but it doesn't feel anything like that at the moment. Hopefully it'll warm up soon. Just like to welcome new members. We've got one new member this month, that was Trevor Hewlett. Visitors and special guests, thanks Paul from Dayton, Nevada in the USA for joining us. And Gary all the way from across there as well. And of course, all our current members, thank you, welcome back, and thank you for joining us once again. Okay, September birthdays, it's a busy month this month, starting with Ethel there. In fact, I had to redesign the slide here, fit all the names in. So just bear with us a little bit. Alan Stewart and Dane Blow, birthdays today. Happy birthday, and Ethel yesterday. Quite a few of them. So we've got a few parties this month in September. Hopefully we'll get invited. And Pierre Dippenaar, the end of there. Well done, happy birthday to you all for September. Last month we forgot to mention Derek. But then he does have that cheeky slogan stitched onto his flying suit saying, "I refuse to grow up," so maybe we forgot his birthday. So happy birthday, Derek. Sorry about that. Okay, here's the mystery aircraft. Any of you know that airplane? Can you please send on chat at the bottom of your screen the answer, and send it to the host only, because if everyone reads it, then they'll all cheat. And it won't be a fair competition. Okay, previous minutes, they were emailed. Proposer?
I'll propose that, Neil.
Thank you, Carl. Sean, and the seconder?
Carl.
Thank you, Carl. Okay, that's good. Chapter Finances, Mark Clulo. Can you give us a quick heads up there? Mark, are you there?
Now, can you guys hear me?
Yeah, we've got you.
Okay. Yeah, as you can see, really not much happened in the month. We got a bit of interest, 2,500 Rand, some bank charges, one member paying. And on the right-hand side, you can see our bank account and savings, 643,000, a little bit in the bank account. And our EAA Chapter 322 is worth 646,000 Rand. That's really it.
Right, thanks, Mark. So we still got a bit of money left. Okay, just on the MAG program, don't forget to scan the QR code. We'll display the code for a while after the meeting has been finished. So if you want to scan it with your phone, you've got an opportunity, you'll get points for that. Don't forget that with the MAG scheme, we've got a trip in line to Oshkosh for the lucky winner. And everybody is eligible for the draw, but the more MAG points you have, the better chance you've got of winning the prize at the end of the day. And then future events. We'll have a pancake and coffee station at Krugersdorp Airfield on Sunday morning. If anyone's on the airfield wants to pop in, come and have a cup of coffee with us. Tail draggers, big excitement. That's basically our first fly-in competition, 18th of September. I'll get Richard to give us a little rundown on that. EAA October gathering, 7th of October, and we're investigating the possibility of doing a Zoom and a physical hybrid type meeting for that one. We'll keep you informed. I think it's time we had a bit of social activity again. And then don't forget our AGM, which is the 3rd of November, and we need volunteers, please, for the committee. Committee's getting tired. Okay, tail draggers to Warmbass. Richard, you there? Richard there?
Yes, I'm here.
Okay. Can you, Richard, why don't you just let us know a little bit about it, how we can join in, how to qualify for the event, and what we should do when we get there, and any other arrangements we should make.
Okay, thanks, Neil. Yeah, the fly-in, we've decided to call it a airmanship competition. So from the moment that you join 5 miles inbound to Warmbass, you will be judged. Obviously, the COVID rules will apply, and scanning will take place on arrival, sanitizing, register. There's supposed to be less than 50 people, but the first 50 will be there for the airmanship competition. The next 50 will be for protesting against the empty skies and so on and so on and so on. So let's try and keep this within the rules as far as we can, but we're not going to show anybody away. We'll keep social distancing as far as we can, as far as possible. Arrivals will be from Friday afternoon night, with guys camping on the airfield and bed and breakfast available in town. If you need any information on that, you can just WhatsApp me with your requirements, and we'll help you with contact details. Due to the fact that we're not allowed to have so many people on site, we decided not to overcrowd the event with staff. So what will basically happen is we will have bride packs available for sale, and you'll just have to buy it yourself. Unfortunately, we can't, get too many guys in there, just to prepare food. So there'll be bride packs available Friday evening, Saturday morning, and Saturday afternoon. Sunday morning we'll have breakfast rolls that the guys will make. Bar, due to the COVID, we're not allowed to have we can't get a temporary liquor license, but you please WhatsApp me your liquor requirements for the evenings, and we will pre-purchase it for you. Then it's all legal. Avgas and Mogas will be available as well, but try and give us some figures on your requirements there as well. We couldn't organize ATC in such a short time because obviously the previous date lapsed, and we had to pre-book them by about 3 months. So what we'll have is ATIS broadcast on 120.20. Basically, you'll get the QNH, your estimate of wind and runway in use. You'll join over at the 2,000 feet AGL for the unmanned joining procedure on whichever runway is in use. We will man 120.20 for additional advice, but please listen out from 5 miles inbound, and we will be able to give you the information required. Parking, as soon as you've landed, we'll have marshals on the ground to show you the parking, and there's also grass landings can be accommodated. You can see from the picture there on runway 21, just on the western side of runway 21, or the northwestern side, you'll see the yellow line there. We'll have a landing strip there right next to the runway. We'll mark it out as well. The yellow mark is the taxiway, basically for the aircraft to go to the camping sites and so on. And but you'll have to ask for the landing on the grass strip, so we can just make sure that there are no aircraft on the taxiway. It is very smooth, and we've just had some guys with the big expensive tires requesting grass landings. The safety officer will have to give you the go-ahead there. So once you've joined overhead and we've got everybody away there, then you can take the grass runway. From the intersection to the parking area, if you're landing on the 03 direction, you will land between the yellow line and the tar runway. Parking will be in that spot indicated there, the yellow area, and also camping will take place there. If we do not have enough or too many people, we'll be able to camp in front of the hangars. Brucens are available, and all the facilities as and when required. the area is quite smooth. We've done quite a bit to get it level. This is the first fly-in, and due to the COVID, we also had a bit of a snag trying to get everything sorted. But I think the airfield's in pretty good shape. We've got the control tower that we used to have at Nailstrom that we moved over to Warmbars, and we actually just erected it yesterday. So we will have that sorted out for the ATIS and Nigel, the safety officer. Well, I think the main thing is for the guys to come and have fun and enjoy the weekend. And let's try and limit the drive-in spectators. So if you have people driving in, we will maybe just ask you just to give them give us some kind of indication of who's driving in. Otherwise, we're going to get the whole town in there, and I'm sure there's more than 50 people in Warmbars, and then we won't be able to have anybody flying in. I think that about covers it. Yeah, we've got a couple of numbers, but you all have my number, so you can just WhatsApp me with your requirements, and I can just answer you. Unfortunately, sometimes I'm not available on my phone during the day, but I will definitely answer WhatsApps. If you want to write down my number, it's 082 490 6227. You can just WhatsApp me anytime, and I'll answer it as soon as I can. The runways will be 21 and 03, and I think we will most probably be using 21 most of the time just for convenience. Warmbars is a very unique place that you've always got a crosswind. So whether you're getting it from the left or the right, you're going to get it. So I think 21 will be used most probably. And if there are any questions, you guys are welcome to ask me.
Okay, any questions from anyone? Thanks, Richard.
Yes. Question from Jeff.
All right.
Yes. Please can Richard warn everybody that to the southeast there is no low flying over those areas. They report you with alacrity. So just be aware that you will be reported. How do I know? Let's leave it there.
Okay, the name of that place that Jeff's talking about is Sondela. Just have a look, and it's actually marked on the map.
Cool. Okay. Thanks. Yeah, we won't ask any more questions, Jeff. But thank you for the warning.
Okay.
Okay. Thanks, Richard.
You just have to keep a lookout for birds as well. We've got a lot of bird activity lately, and on your approach on 03, there are power lines. But if you're that low, then you're actually already in trouble. So, but generally, a very aviation-friendly area, except for Sondela. The main reason is they had a rhino orphanage, and that was a stage when everybody still thought that every aeroplane that flies over wants to steal the rhino. Little did they know we don't need it. It's also a sanctuary for injured animals. So Harvard at 50 foot does cause a bit of distress for these little animals that were that's just gone through a lot of distress. But generally, the whole area is very aviation friendly, and we'll let you guys fly around and show you different spots as well.
Cool. Quite understandable. Richard, we'll put your number out on the WhatsApp chat group.
Okay. Okay, Neil, we have requested a NOTAM, right? As soon as I get it, I will forward it to Richard and we'll broadcast it. Basically, all it's going to say is that there's increased air activity in the Warmbars area.
Cool. Thanks, Nigel. We'll look out for that as well. Okay. All good on Nailstrom. We're looking forward to it and looking forward to seeing you all and seeing some aeroplanes again. Okay. Next, Rob Yonkers, if you can just give us a quick update on SA, CAA and ERICA.
Okay, good evening all. I'm just going to give you some feedback on some Aero Club matters. So firstly, we had call it extensive meetings last week, firstly with the executive manager of operations, Simon Sekwabi, and his team, which included airworthiness and also personnel licensing. And we've talked about quite a fair amount of subjects. The first one, I think, on everybody's mind is the ATF renewal delays. So there has been, I'd say, an extensive effort by the CAA to improve they call it the delays, and they are now essentially getting the inspectors themselves to run with the applications rather than that there's middle people involved like the currency fee officers. So those people have been cut out. So the activities directly with the inspectors. The other thing that they're looking at is the acknowledgement of receipt of documents. They have their IT department looking into how to give everybody who submitted documentation acknowledgement that they've received it and that there's progress with it. And they're also working to return return to the promulgated turnaround times, which in the case of ATFs is 30 days, even though we know that 30 days is also still, I'd say, a stupid number. We are working to see how they can accept that they can actually process them faster. The signature of ATFs, which was a big issue up until recently, where documents were being transported between Rand and Midrand, there's no more documentation that is sort of moving physically between those two sites. Everything is now being done electronically, and signatures are also being done electronically. So the Rand offices will receive a digital signature, and then they will stamp the ATF off, and then that same digital signed ATF will be sent on to the owner of the airplane by email. That also then constitutes a valid document that you can go and fly with, while the physical document actually catches up either by post or by courier. That then is decided by the owner how to get the physical document. So I think there has been, I'd say, good, I call it improvement in the way they are doing things. We just need to see if there is traction on actually on that improvement. And we'll await you for you guys who are in the thick of things if there is going to be an improvement. And you can obviously feedback to call it your EAA team or to myself if you're still finding difficulties. Then on the renewal system that we proposed as the Aero Club, we have had a go-ahead by the CAA that they will entertain such a system, as long as it's a parallel system, because there may be people who want to directly deal with the CAA without going through, I'd say, a more digital system. It will work very much similar to how we did the continued airworthiness and maintenance position flights, which most of you used, about 2 months ago during lockdown. So we're looking at a similar kind of process. So we'll be working with a team to put together a specification and work with the CAA on how we're going to interface with them. Yeah, one of the things that the CAA also have been saying is that a lot of delays being experienced is because the owners or ATF submission teams that are involved, they submit documents that are incomplete. So that also adds to the delays. So one of the things that we are trying to see with this automatic renewal system is that there's a documentation check that is done by the Aero Club or or EAA members that will volunteer for that, to make sure that the documentations that is submitted is accurate and correct. That will ease up a lot of the frustrations that one finds. Then one of the other things we talked about is the 90-day inspection after ATF expiry. So there was a lot of reasons given why that is the case, but they have agreed that that particular point can be revisited, and we will engage with them on that particular topic. even though it's not exactly in the regulations, they are basically taking the type certified regulations and applying the same rules to the non-type certified. Other activities were, or other discussion was about the documentation evaluation fee of 850 Rand. And again, we will be engaging with them to see if we can get that removed. On national pilot's license reissues, that which is happening on a yearly basis, we have proposed that we must look at an MPL that has an initial issue, and then yearly after that, look at the verification rather than a reissue. And they are quite amenable to that. The only problem is that sometimes people's features in terms of their facial recognition on photographs changes over time. So we suggested that we can look at a 5 or 10 year reissue, similar to what you do with passports and vehicle license or your driving licenses. So they are amenable to listen to that that kind of logic. And then I think just a final point is that we have agreed that there will be a standard sort of engagement with the CAA as the Aero Club, representing all our recreational sections at least once a month. So I've already, what I told you now, I've already sent around to the council members, and they will then provide any inputs to these monthly, say, senior meetings with the CAA for any issues that need to be tabled. So that's the feedback that I have on call it Aero Club matters. I think just another point, maybe just for interest, we have completed the centenary yearbook. That is now at the printers for printing. I don't know if I can share my screen. Just looking at what I can share here. Okay, you can probably see what that screen looks like. That's just the cover of the book. It has 474 pages in it, and edited, as you see at the bottom there, by John Ilsey. And we had, I think, a lot of you, in fact, did contribute to a lot of the writing of the book, and it covers, a mix of historical information on recreational aviation in the country, and of course, the more contemporary happenings in the last couple of years. So those of you who are interested in obtaining a book, we are taking pre-orders. If you just go to the Aero Club website, you'll see one of the tabs there to make your pre-order, and it's just, you just fill in a Google form and then you can make a pre-order. And as soon as the book is printed, we will start to satisfy the pre-orders. Okay, that's basically what I have to cover. I don't know if there's any questions. Either put in the chat box that I can answer, or I take questions if somebody wants to know anything further.
Thanks, Rob. There was one question in the chat box. Marina Roberts asked, how can we get rid of physical documents? I think that's something perhaps we work into in the future, is it?
Yes, exactly that. Part of what we want to offer in terms of the digital system is a lot of the documentation on ATFs are repeats every year. For instance, your aircraft registration document never changes unless you change hands with it. So if we keep a vault of that aircraft's documentation, then you only will submit, I would say, the documents that have changed from one year to the next. Then you're only talking about 1 or 2 documents, not not much more. Things like your weighing document, for instance, you do every 5 years. You don't need to keep providing it every year. So yes, that is what we're looking at. And of course, the other, I'd say, question that we are, that we are putting to the CAA, why why is the ATF such an important document? Because that doesn't really add to the airworthiness of the aircraft. It just is having to provide a raft of documents, and for what for? So we want to try and see if we can lighten that load as well. But that's, something that we engage with them as time goes on.
Oh, sorry, mute. Okay, great. Thanks, Rob. You have no doubt you'll update us further down the line as well.
Yes.
Thanks very much. We appreciate the great work that you guys are doing there.
Yeah, you will have seen the MailChimp that I sent out, I think 2 nights ago. On that just summarizes more or less what I've just indicated. You're free to read that as well.
Sure. Thanks, Rob. And guys, get your orders in for that Aero Club book. I know I've ordered mine. Could be a great coffee table book to have around 100 years of aviation, Aero Club. It's quite a milestone. Great. Thanks, Rob. Okay. Next. Paul, we're ready for you. Sorry to have to put you through all the talking. We screen share with you at the moment. Rob, will you set that up for Paul to share the screen? You there, Paul?
I guess I can't. I'm not shipping video at this time. That got stopped.
Okay. Okay, he's opening it up for you now, Paul.
Okay.
Okay. Feels like we're in mission control here. We've got.
Yeah, let's see. It still won't let me start the video, but I think you can hear me.
I can hear you. Hold on a sec. Is it? Maybe I've got to stop share here. Hold on a sec. I think it's trying to find you on the list of participants there.
Now I can share the video. Okay, very good. Very good.
Great. Okay, welcome, Paul, and thank you very much for joining us. It's such an honor for us to have a guy like you, and thank you for.
You bet. You bet. Well, we'll go ahead and get started if you're ready. Let's see. I'm going to share a screen, and I'm talking to you from smoky western Nevada. We've got all sorts of fires going on out here. And let's see if I can share screen 2. Okay, you should be seeing a large mission control patch. Can you confirm that?
Confirm that? Yeah, we got it.
Okay, very good. So we'll get started. It's a real pleasure to be here with you today, and I've been doing an awful lot of these virtual visits, and actually that's one of the benefits of the whole COVID era, and that it's very unlikely that you would have paid my expenses all the way to South Africa to chat with you, but it's pretty simple for me to talk for an hour from here at home, and I'm doing that with a lot of different chapters, so it's really, really nice. So what I want to do today is go over a few slides from a presentation that some of you may have seen if you've been at Oshkosh at AirVenture. It's called Lessons from Mission Control. I should give you just a little bit of background for those who don't know me, and most people don't. I got my start rebuilding J3 Cubs when I was 13 years old. I was pumping gas, sweeping floors, working on Cubs, and getting an hour of flight time at a time at a chance, or a half hour at a chance. I soloed when I was 16. I was licensed at 17. So I've been basically flying all my life. I went to the U of M from aeronautical engineering. And I really planned to spend my entire career building airplanes, but I took this detour into the space program for a variety of reasons and coincidences that happened. And I spent 34 years flying space shuttles. The first dozen years I was a flight controller, and then I was selected as flight director, became lead flight director for the human spaceflight program. And so it was a fascinating time. After I did that and retired, I ended up with Kit Planes magazine. They asked me to run the magazine when I retired from NASA, and I said I didn't know anything about running a magazine, but they said that's okay. We got experts on that, and you're an expert on experimental aircraft, so that's what we'd like to have you. And so it's given me the chance to fly lots and lots of different machines, and go all around the country and the world to fly interesting experimental aircraft. So it's I've been pretty fortunate aviator. And today I get to go out and fly my own little jet, which is a home-built little experimental. subsonics. As a matter of fact, I had it out this morning doing a little reconnaissance on big fires we've got going on out here. Kind of got chased back home because of the smoke. So so I've already been out flying and having a good time. But what I want to talk to you a little bit about today is this aircraft, the highest flying, fastest flying airplane ever built, was the Space Shuttle, and it's too bad that it was retired. But we did learn an awful lot from it, and one of the things we learned is how to think our way through experimental aircraft and the operation and building of experimental aircraft. When I got started, I was in mission control, which was a pretty modern place, but we made it much more modern. The thing that people don't realize is that mission control really grew out of the 1950s, the X-planes, the rocket ships that they were flying out of Edwards when they started off having telemetry and some people on the ground helping out people. Space programs are very, very large, very, very big, and there's a lot of things you can learn about flying as well as building. That we learned and that we practiced every day in mission control. First off, our goal is always safe and successful missions. It doesn't do any good to kill people when you're flying. There's virtually no reason, as they say, to fly into a thunderstorm in peacetime. There's no good reason to do that. You want to be successful. If you're building your own airplane, you're taking it up for its first flight, you want that flight to be successful, and it's not going to be successful if it's not safe. So those are two things that we have to make sure of, the safe and success. So here are things that we learned along the way. First is to understand your real risks. And I always like to show this picture of a nice thunderstorm because we're all afraid of weather. And we've all read many, many stories of pilots flying into bad weather and coming out in pieces. And it's an awful thing, and it's very deadly. But the truth of the matter is, in experimental aviation, we have very, very few weather-related fatalities. It's simply not the emphasis area that you need to worry about. You need to worry about engine failures on takeoff. That's 25% of the fatal accidents here in the United States for experimentals in early flights. You need to worry not so much about structural failures. That doesn't happen very much, but you need to worry about pilots doing stupid things with airplanes. You're more likely to get killed if you make a low pass down the runway and pull up sharply and stall and spin the airplane than you are flying into the thunderstorm. So you need to understand your real risks. And we learned this over and over again in the space program. And another example I'll give you is I was a firefighter for 25 years, a volunteer firefighter. And we spent all of our time training to make our firefighting safer. Working inside in a burning building with hoses and having air packs and protective gear, and how do you fight the fire and things like that. When if we really, really wanted to save firefighters' lives, what we needed to do was send everybody to the gym, because 70% of all firefighter accidents or deaths in the service were due to heart attacks from people who are not in shape. And so understand your real risks. Step back from what you're doing and thinking about what your real risks are. Next thing, always have a backup plan. Mission control and the space program is well known for redundancy and thinking about what comes next. No matter what, you should always have a backup plan. Even if that backup plan isn't particularly good, you want to at least know that you've thought about it. And an example I'll give you, back in the space shuttle days, the space shuttle payload bay was 60 feet long and 12 feet in diameter, and we carried large payloads back there. And in order to, when you got on orbit, you had to open the payload bay doors to do anything and also to reject heat. And those doors had to be closed for entry or you were going to break up. In order to close them, they had latches all along the spine of the spacecraft, as well as on the forward and aft bulkheads. And if there were two sets of motors to drive those latches, so there was a lot of redundancy, but if those motors didn't work, you could go out into the payload bay with a spacewalking suit and put clamps on. So you always had a backup plan to get them closed. The problem came one time when we realized that we were flying payloads that were so large that there was no way, once the door was closed, to get a person back there to close and clamp the aft latches behind the back of the bay. Somebody realized this, and suddenly we were stuck. We couldn't launch. We were getting ready to fly a mission with a very large payload back there. And someone said, we need to go off and solve this problem. Well, myself and another guy went off, and we went and sat in our office and we thought about it, and we said, you know, they're not going to like this answer, but it'll work. And the answer was, if you got in this situation, you would open the doors, you would send a spacewalking astronaut to the back of the payload bay, then you'd close the doors, you'd have him put the clamps on, and then the person would ride home in the payload bay in the spacesuit. Now, that sounds pretty radical, and it would have been pretty radical, because once you got on the ground, the only way you were going to get him out was to cut a hole in the side of the vehicle, and you had to do it fairly quickly because he'd overheat in the suit. But it would have worked, and we were allowed to go flying with that fourth level of backup plan. So always have a backup plan. If you're going to be taking off in your brand new experimental airplane and you've got a 5,000-foot runway, your backup plan, if the engine quits right immediately after takeoff, is to land straight ahead. You should always have a place to go. If you have no place to go at some point in your takeoff plan, other than turning back, which is a very, very bad idea. Most attempts at turning back end up in a fatal stall spin. You probably shouldn't be flying out of that airport. So think about your backups and what you're going to do if things go wrong. Coupled with backups is redundancy. So there are two ways to assure that a function is going to happen in an aircraft or a spacecraft. One is to make it extremely reliable, the point where it just simply can't fail. The other is to make it very redundant, so that if the first system fails, you've got the second system and maybe the third system and maybe the fourth system. In the shuttle, this is a great example of the redundancy wiring scheme of the glass cockpit in the shuttle. When we converted to a glass cockpit, I started looking at this drawing and realized that my brain was getting a little old, and I wasn't sure I was going to be able to memorize all of the different redundancies, until I realized that it was so bloody redundant that there was almost no way you could end up with no displays. You had to be about 5 failures deep, so it wasn't too bad. But if you are building a complicated aircraft and you need to know how things are connected, how things are going to work, how things are going to fail, and think about where your redundancy really is. And in most of our cases with experimental aircraft, realize that redundancy is wonderful, but you've only got one engine out there up front. And if that quits, you've got much bigger problems than simply losing your display screens. So think about your redundancy and definitely understand it. Next, keep things simple. I have seen guys build aircraft that rival this. This is the flight engineers panel on a B-29, I think. And when you ask them what kind of complex operations they do with that airplane, they say, oh, I just fly it in the day and go for a $100 hamburger, and I never fly in weather. And I ask them, why in the world is it so complicated? What you want to do is build an airplane that is as complicated as you need it and no more complicated. Complication for its own sake adds no purpose. You want to keep your flight project in scope. You always want to know exactly what you need to do and don't do anything more. Perfection in design comes when there's nothing left to be taken away, not when there's nothing more to be added. All right. So keep things simple. Next, you want to provide margin. Always provide margin. Now, the obvious answer to margin is, or the thing that people think about is structural margin. This is a Mooney aircraft, and this was from a magazine ad that they put out many, many years ago. And they have 20-some or 30-some employees standing on the wings of this. Obviously, there's plenty of structural margin in a Mooney. But you also have margin in your operations. Know where your margin is. If you're taking off on a first flight and it's an aircraft that's unproven, a design that's never been done before, you might want to wear a parachute just in case you have a structural failure. Your margin in that case is in your parachute. So you want to think about structural margin, equipment margin, having more capability than you need, more power than you need, more electrical power than you need. And then in operations, you want to have margin in terms of what you're thinking about. Weather is still a consideration if you're flying cross countries, and you want to always have a place that you can land. If you're a VFR pilot, you always have to have a place where there's no weather between you and where you can land. doesn't be where you intended to land, but you need a clear path to landing. If it's going to be in bad weather, if you're going to be flying IFR, you always have to have a good, solid diversion point that you can go to, and that's operational margin. Next, we want to make sure that you're making data-based decisions. I can't tell you how often we see people make bold statements about this is what you must do with an airplane. And when I say, where's that written down? They say, well, I don't know. Charlie at the airport always told me that. And Charlie must know because he was taught by somebody, by Fred. And Fred learned that from someone else. Well, that's not real data. That's just hearsay. In mission control, we have an engineering support group, which is very large, and they have a very big room. And over the door to that room, they have a slogan, and it says, "In God we trust. All others must bring data." You always need to know where that data comes from, and you also need to know that the data is reliable. You know, these hangar flying opinions are just that. They're opinions. You know, so ask people where they're written down. If you wanna start a great argument in a pilot lounge, just walk in and say lean of peak, and then walk out, and you'll have all sorts of arguments get started. But evaluate the sources. Don't trust your life to what we call rumors and old wives' tales. And finally, don't give in to peer pressure. Do what you can prove is right. There are a lot of things that are common opinions in aviation, and they're not necessarily true. And if you have good, solid data to back up your position, then you need to go with it. You need to think about it. Another thing we learned in mission control years ago was that testing is better than analysis. So in the early days of the space program, if they wanted to know the limits on a piece of hardware, they would test it to destruction. They'd make a dozen of these things, and they would test them until they broke, until they were destroyed. This picture is a picture of testing a wing in a jig. And that's the same kind of thing, is that you want to test to destruction. And that's how it was done for many, many years. Then along came computers and these marvelous, marvelous engineering programs that like Nastran and the like, that can do all that analysis for you. But those programs are only good as the mathematical models on which they're built. And those mathematical models are built on theory. And if that theory has not been tested, then you don't really know whether your model is any good. So when I want to know whether a new design is going to work, I usually will build one and I will break it. If it's a bracket or something like that, I will go and test it and make darn sure that it works. I'm not just going to rely on mathematical modeling unless somebody has proven to me just how good the model is. The next thing is knowing how your stuff works. This is becoming more and more important. So let me explain. Knowing how your stuff works, this is an electrical drawing from the shuttle, a very, very small electrical part of the electrical system, and how all of the various electrical buses were interconnected and how they could be switched between each other, and what pieces of equipment were connected to which bus. Knowing how to work something is what we expect from a technician. We give them a procedure, they learn the procedure, and they work it. Knowing how it works is a job of an engineer, someone who actually understands beyond the procedures to understand exactly how things are built and wired. This becomes more important when you have a three-screen EFIS and 2 GPSs, and you don't really, and you need to know how those GPSs feed the screens and how they feed the transponder and the ADS-B. And you need to know that if GPS 1 loses lock, what do you lose, right? And so if you lose a particular set of features, what do you still have left? We need good, deep knowledge, especially in the experimental airplane world, of how things work. So you want to make sure you know that. We run into this a lot when someone buys an instrument panel from one of the big companies that likes to build instrument panels, and then they just hook it up in their airplane and they have no idea how it works. That makes them a technician, not a real pilot, all right? So you want to actually know how your things work and learn how all the software works and how the hardware works. Next, this is a cartoon I love, but it's hard for people to see. We want to talk about flight rules. Now, flight rules are decisions that you make in advance, and they're lessons that you learn and you write them down. And the reason I like this cartoon is you got these two cavemen sitting here and this large woolly mammoth on its back, obviously dead, and there's this itty bitty little arrow sticking out. And the caveman is saying one to the other, saying, maybe we should write that spot down. And that's really what flight rules are. We learn lessons. We learn lessons from training. We learn it from experience, and we write those down. Now, these are not laws. These are not regulations. These are things like it's a good idea to always make sure that you've got fuel in both tanks, so that if you have a problem feeding from one tank, you can go to the other tank, and you don't run a tank dry unless you're over an airport where you know you can land. And then, by the way, that's okay. I do that all the time. So flight rules are really, really important to develop in the cool of the night rather than in the heat of the day. So before you go off on a first flight, you should set your weather flight rules. We're not going to fly on the first flight if the crosswind exceeds 5 knots, if the ceilings are below 3,000 feet, and so on and so forth, whatever rules you develop. And then when you get to the day of that first flight and you've told all your friends you're going to fly the airplane and you've got people out there at the airport watching and it's very important, but the wind is blowing at 7 knots a crosswind, you need to be able to say, nope, I set this rule, we're not flying today. Sorry, folks, we'll come back another morning. It's important to write flight rules and it's important to follow them, right? We do that all the time in the space program. We might have to repeat a flight. We might have to land early, but we wrote the rule to be safe, and so we're going to make sure we're safe and that we can always go back and do it again. My very second flight in my RV3, I ended up on a dirt road in an oil field because of the problem with the fuel feed. The fuel valve handle spun on the shaft, and so the engine quit when I went to switch tanks. I landed uneventfully, and then we were there on the ground, and I'm looking at it, and I finally realized what had happened, and that all I had to do was tighten up the screw, and I could take off. But it was a half hour from sunset. We had said that if we did an off-field landing, the airplane was going to stay there overnight, and we'd come back the next morning, think about it, make sure we're right in our diagnosis, and then fly it home. And that's what we did, even though I could have taken off and hopped back home. We didn't break the rules. I'm not sure how common the phrase that we use in America about a kid in a candy store is, but you need to know your requirements when you're building an airplane. And this goes back to this complication stuff. You know, this poor little girl is just overwhelmed by all the choices she has, and she just wants to have all the candy. And it's just very, very similar to what we have nowadays when we're building these experimental airplanes. Now, some people do build airplanes whose panels look like what we had in the space shuttle, but you need to think about what your requirements are. If you're building something to just go up and fly around for a half hour and landing, you don't need very much. If you're building something that you want to be able to fly air medevac flights in all weather from unimproved strips, you're going to need an awful lot more equipment. And so you need to write those requirements down before you build, and then you need to build to those requirements. One of the biggest problems with people not finishing airplanes is because they keep changing their requirements while they're doing it. And you want to not do that. You want to actually think about what the requirements are up front, and then you want to stick to those, because if you keep changing them, you'll never fly, right? We call that mission creep. Happens all the time. Details count. Details are very, very important, because most airplane crashes are not the result of big monster things. They're usually the result of something small, which it can then be compounded. A lot of people don't realize that that the bolt on the aft spar of the Van's series of airplanes, the RV airplanes, is supposed to be a castellated nut. It's supposed to be a drilled bolt and a castellated nut with a cotter pin. If you replace that with something that doesn't have that kind of protection, it can actually loosen up, because that connection, that spar connection, flaps a little bit, and so the bolt is subject to rotation, and that's a detail. We lost the space shuttle Challenger due to a leaky O-ring on a booster. And we lost the Space Shuttle Columbia due to a simple problem with foam coming off of a tank. Those were little problems. You know, for want of a bolt, the airplane was lost. So it's rarely a single large failure that causes a problem. It's something small. We had a payload that we were going to fly one time. It was the mission that was going to fly right after the mission where we lost the Challenger. And it was a piece of equipment I was responsible for. And it was a pointing system, which would point telescopes, and they'd sit down in the payload bay until you got up on orbit, and then you'd erect that, and it would point straight out of the payload bay. And it had a bumper ring so that when you were pointing, it couldn't bump into the payload bay. Well, there had to be a slot in that bumper ring in order for the payload to sit down, to stow it for entry. And we had flown it once before, and then we were going to go fly it again, and they changed the height of the bumper ring because of different mission requirements, and somebody forgot to test it. And it turned out after we lost the Challenger and we realized we weren't going to fly the mission, they went to take it out, and it wouldn't go through the slot. They hadn't done the geometry right of the slot, and we would have launched that into orbit and then discovered that we had no mission. So it's a very, very small detail, but all those details are important. Again, going back to my RV3 first time on the first or second flight ending up on a dirt road, there was one set screw that needed to be Loctited that didn't get Loctited, and that's why the fuel valve handle slipped on the shaft. Very, very small detail. I had an engine quit and I ended up on a dirt road. So no detail too small. You've got to look at them. Next, we're getting near the end here. You need to learn from history. You need to look at what mistakes other people have made and learn from it, because you will never have enough time in your life to learn all the mistakes by yourself. You need to go out and learn them from others. This was the Apollo 1 spacecraft. We lost 3 astronauts on the launch pad during a pad test in the 1960s because somebody hadn't thought about the fact that they were testing with a pure oxygen environment. We learned a lot from that accident and losing 3 people that were dear to everybody in the program. We still have lost spacecraft. Like I've mentioned, we lost the Columbia and we lost the Challenger, and we lost those, but we learned lessons from them. The best way you can look at this, and one of the most interesting things about the internet is that you don't just have to look at accidents that happen in your part of the world. You can look at accidents that happen all over the world, and you can find databases. The FAA here in the United States puts out a daily summary of every accident that was reported to them that day, and you can learn from that. You can find out that 60% of all the accidents are people running off of runways on landing because they couldn't keep control of the airplane on landing. I find that astounding that we can't figure that out. And most of them aren't blown tires. They're just loss of control on the runway. And so you want to go look at that thing, and you want to study what causes accidents. In Kit Planes magazine, we have an occasional contributor, Ron Wantaya, who does a fabulous job with his safety articles, going back and looking at accident databases and finding the actual cause of accidents, and not just statistically, but the actual written down what was the mistake that the pilot made. And you want to go look at those things, because if you don't learn from history, you're going to repeat it. And closing in here, I want to say that teamwork works. Now, this is a typical flight control team from near the end of the shuttle program. It's smaller than in the early days, but this was about 60 people on one team, and we take a team picture every flight. This was STS-119. This was my flight control team on that mission, and you can have a team in anything you do. It only takes 2 people to make a team. But the advantage to teamwork is you've got a different mind looking at problems. You've got somebody who can say, excuse me, but I don't think you tightened that bolt. Or excuse me, but shouldn't we have a safety wire on that? Teamwork works. You want to make sure that you bring as many people in as you can. EAA technical counselors and flight advisors are great teammates. Some people know I'm on the Home Built Council for the EAA. And under our purview is the EAA Tech Counselor Program and the Flight Advisor Program, and I'm both. You want to find a tech counselor. I'm going to do a tech counselor visit up in Reno this afternoon. I'm going to drive 30 miles to go take a look at a guy's tail kit that he's gotten just started on, and he wants to know if his rivets are any good. That's enlisting a good team. When I do flight tests, I like to have a team no bigger than it needs to be, but big enough to make sure that we're not going to miss anything. And lastly, I want to say that in the end, hope is not a plan. Do you hope something will work, or do you know that it will work? You know, for instance, how many people need to reinvent the light airplane fuel system? There are so many different people coming up with so many different ideas of how to get fuel from a fuel tank to an engine, when we have a pretty reliable, simple system that's been used for 90 years now that very rarely quits if it's built properly. And you need to think about whether you're hoping that something is going to work or whether you know it's going to work. If your answer is that I'm going to go fly this airplane because I hope it will work, you probably shouldn't fly that airplane. You need to know that you've got everything covered. Always stop and ask yourself, what are the little things that are bothering you in your head? What are the things that you're worried about? If there's anything that you're worried about that could cause a safety of flight issue, stop, fix it, and then move on. You have to be honest with yourself. If you have a doubt, follow it up. So hope is not a plan. One of the primary rules of mission control. And my last little slide is a little commercial. We have a new book out. It's called Shuttle Houston, My Life in the Center Seat of Mission Control. It's available online from most of the booksellers. I'm not sure if it's available, where it's available overseas. But an awful lot of the stories and lessons that we've learned from years in mission control are contained in there. And you can pick it up, and if you do, I'd love to hear a review of it and see what you thought. So that's basically what I had. Let's see if I can stop sharing my screen. Somebody might have to do that for me.
We're just having a look at that, Paul, to see if we can stop sharing from this side.
Yeah, I gotta, for some reason,
Yeah.
Oh, okay, you did it, good. And so with that, I'd be happy to take any questions that you might have.
Okay, anybody got a question for Paul?
I'd like to, Paul, just, you know, what you have said here is so awe-inspiring, and your talk was so thought-provoking. I sit in awe of NASA and what the US space program has achieved with you as mission controller so often. And I've seen both Kennedy and Houston mission control many times, but never during a launch and with live activity, of course. We all really appreciate a guy of your ilk involved in EAA and how this kind of input strengthens the movement, and of course, especially to our EAA 322 so far from Oshkosh. Big thanks, man. There are many greats I've listened to at Oshkosh, such as Bob Hoover, Chuck Yeager, Bert Rutan, and I also loved Sean D. Tucker and others, and have had the enormous pleasure to meet legendary astronauts, as we were speaking earlier, such as Michael Collins and Buzz Aldrin, and others on board my flights in a 747. Your book, if you note there, if I was given the full screen, that would make things a lot better, Paul. Just because I want to show people that your book, Shuttle Houston, Life in the Center of Mission Control, which I know it was only released in July this year, and has had some great reviews. The one I like most is by that high-profile fellow, Gene Krantz.
Yeah, there's Gene.
Yeah, got to get it. I believe it's available from Amazon. And of your personal toys, I really love the most is your Subsonics jet. Thank you so much, Paul. It was really, really a terrific talk. Thanks.
Well, thank you. I'm glad you appreciate it. I
Uh,
see
I'll
somebody.
tell you that everybody that's been watching has probably been sitting with their mouths hanging open. Lovely.
Well, I see somebody asked a question that said, I'd like to know what your best fuel supply system would be. Well, an awful lot of that depends on the airplane configuration, to be honest. I like to have as fewer components in the system as possible. And so if it's a high wing airplane, you just go from the tanks to a fuel valve selector, and then into a gascolator or a fuel filter into your fuel pump. And if you cut down on things, you're going to have if you cut down on things, you have fewer things to fail. The best answer I can give on fuel system design is that if you are building a kit, use what the kit manufacturer came up with, because they have many hours on that airplane and lots of experience with why they built it the way they did. If you want to make a change, talk to the kit manufacturer and say, this is what I'd like to do. But there are a lot of ideas out there I've seen that are fairly complicated, that have failure modes that can give you problems. So I can't give you a single answer on fuel systems, but keep them as simple as possible. Any other questions?
Yeah, Paul, I don't know if you ever read any of Tony Bengelis's books on the fuel system. He said if you've got a high wing and you run out of your fuel pump source or what's pumping the fuel in the high wing,
yep,
you've got bigger problems to worry about that not getting fuel to your engine. In other words, gravity has disappeared from the earth and
yes,
fade off.
yes.
Yeah. So
yes.
keep it simple is always a good one. Yeah. And Paul, will you be in Oshkosh next year?
I hope so. If they hold it, I'll be there, and we can, and I'll be around. I usually am giving talks and things like that. So, we were hoping we'd be back for our November board meeting in Oshkosh, but they've even canceled that. We just can't seem to get a handle on how to keep things, we can't get a handle on how to prevent this, although it should be obvious. Let's see, I see somebody said, how much change do you see the privatization of spaceflight will change the industry? I really think that privatization is a great thing. We've seen Elon doing a lot of amazing things with SpaceX, and the short answer is that when I go to get on an airliner to fly somewhere, I don't get on United States National Airlines. I get on Southwest or American or Delta or something else, because those are private companies that provide air transportation service. And in the same way, I think that we need private companies providing space transportation so that NASA can get back to spending its time and money on exploration, getting out beyond low Earth orbit, going back to the moon, going to Mars and the like. So privatization is pretty simple. It's a good thing, and we need to be pushing it. Any other questions? I'm going to have to get off here quickly because I've got an online meeting that's coming up. So anyone else?
Right. Well, that's great, Paul. If you've got to get going, we'll let you get back into the desert there. And once again, thank you for all you've done for us.
Okay, thank you so much, and fly safe, and hopefully we'll meet some of you at Oshkosh next year.
Sure.
Paul,
Thank you, Paul.
The noise around me, the applause in the area is deafening. Well done. Thank you so much.
Well, someday I do need to get down there to South Africa. My wife did her PhD. She's a geologist. She did her PhD in South Africa, and spent quite a few trips. Did quite a few trips there. She keeps saying we need to go there so she can show it to me. And one of these days I'll get down there. So maybe we'll meet you there.
Paul, if you ever come down here, you know where to find some accommodation, whatever. And my
You bet.
daughter and her husband are both geologists here in South Africa, so we've got a
Excellent.
good base to work from. But you're
Okay.
welcome.
Okay, thank you very much. Bye-bye.
Thanks, Paul. Bye-bye.
Yeah.
Okay, great, guys. Thanks very much. I think we'll call it a day there. That was a really good talk by Paul. I think we could learn a few lessons from that shuttle mission. What we'll do, we're going to leave the screen on for a little bit here. If anyone wants to scan the QR code, it'll be here for a while. Just any answers on the mystery aircraft?
You said an RV5. Oh,
That's, sorry, I'll just get it back again. That's an RV5. It was a one-off design, metal design. Initially flew with a half VW engine and now with a Rotax two-stroke. That was taken at Oshkosh. I didn't know Dick van Gunswegen could design an aeroplane that looked that ugly. But that's what it is. Okay. Okay, just our next meeting is going to be Wednesday, 7th of October. And as I say, we'll explore doing a hybrid format for that. Maybe at the auditorium at Rand. We'll be going into it in the next week or two and let you know. Okay, we'll leave the screen on. And if anyone wants to scan that, please go ahead and scan it and get your points. Thanks, guys. And I think that's all from me.
Neil, well done. That was an absolute fabulous get together. It really was terrific. Jeepers, and that Paul Sky is absolutely amazing. And everything he says, well, you can see why he was a controller in a big organization like that. Fantastic. Absolutely lovely. Well done.
Thank you, Carl. Thanks. And thanks for all your input into that as well. I really enjoyed Paul's show. And just a note that he's also agreed to do a Flying Legends talk show on flying the shuttle sometime in the future. So just keep a lookout for that and we'll update you when that'll happen.
Neil, once again, thank you for including me from Florida and the US. It's always a pleasure to see all of you, and I'm glad to see that things are starting to loosen up for you. That's good news.
Thanks, Gary. We definitely, we're just about back to normal flying now. So a lot of happy people around.
Great.
And, yeah, I hope you're still flying that Vaga there.
Yes, and we're slowly trying to figure out how to get back to Young Eagles flights and some of the things that we were accustomed to doing. So it's a slow process, but you got to remain optimistic.
Yeah, I think so. We'll start thinking about that type of stuff again soon. It's been a tough couple of months for us here. We were really shut down in this country. But thanks to Rob and those guys, Rob Yonkers, it looks like we're getting back there.
Well, take care, and we'll
Thanks,
see you.
Gary. You too.
Bye-bye.
Thanks, guys. Okay, I'm going to go quiet now. I'll leave that screen open for a little bit if anyone wants to scan that QR code. And we'll chat to you all in the week. We look forward to seeing you guys at Warmbass and maybe Krugersdorp on Sunday if anyone's around. Thank you.